Hooke's law states that the force needed to extend or compress a spring by some distance is proportional to that distance. F equals kx. K is known as the positive spring constant, which is unique to different materials. For our project, we have chosen to prove Hooke's law by testing both a red exercise band and a blue rubber band. We hope to find a linear relationship between force and distance and a different spring constant for each band.
We did 3 trials of 12 measurements for the blue band. We took those data points, we put them into Excel, and we plotted them on a chart. Then we added the trend line that starts at 0. Because it's linear, we know that the slope is going to be the spring constant for the blue band. In this case, it's 5.28. I also added an R-squared value, which is a statistical calculation for the error of the line fitting the data. Here it's 0.94. What we want is 1, so we're pretty close. We took the same measurements for the red band, and we plotted the data the same way. The slope here is 3.74. That's the spring constant, which is different from the blue band. And then here's our R squared, which is 0.99, so we had even less error.
Here's a car that looks normal to us. And here's a car that looks a little funny. This was essentially caused by application of Hooke's law. Now it's a little more complicated than this, but to put things in simple terms, you can think about a car suspension system as a system of completely interconnected springs. Therefore, movement in one part as a result of an applied force will cause movement in another part, and the angle is derived from dynamics. In that last example, you could see one side of the whole car frame at a very low height, and the other side was much higher. This is very important for balancing of the car and can help it not flip from centrifugal force.
The results obtained from this project confirm Hooke's law is true. The materials whose displacements have been shown early in our presentation are in their elastic region. As such, a linear relationship between the force applied and their displacement was shown in the graphs. This indicates that as a force is applied, the material it displaces is directly proportional. Though the data appears to represent physical results of the project, there are a number of possible errors. User error when reading the measurements from the ruler, such as parallax error, by reading the measurement from an angle or choosing the closest marker to represent the measurement. Inaccurate forces being exerted over the material, and the overall calibration of the apparatus being used to conduct the project may have been inaccurate. Lastly, we would like to thank Shell for providing us materials for this project.